Hello and welcome to Byju's. In this particular video, we will be looking at the JEE main examination, which was conducted in April 2019, and we are going to analyze the mathematics paper of the first shift. So in this paper, there were 30 questions. Out of these 30 questions, 16 questions came from the 11th standard syllabus and 14 questions came from the 12th standard syllabus. So the balance is slightly in the favor of 11th standard over 12th standard in this particular shift of the question paper. Now let's divide mathematics into 4 different sections. There is algebra, which includes chapters such as binomial theorem, sequences and series, complex numbers, matrices and determinants, and all of trigonometry. So this is the big umbrella called algebra, and from this big umbrella of chapters there were 9 questions, and out of these 9 questions there was only one question which is actually very difficult and a couple of questions which I would say were moderately difficult. But a big number of questions, 65-70%, 66.6% of the questions, 6 out of 9 questions, in my opinion, were very simple from algebra. When you talk about whether these questions were lengthy or not, I would say that 50% of these questions were lengthy, the others weren't lengthy. So, of course, mathematics paper tends to be lengthy. So remember that you have to actually allocate a lot of time because not every question will have shortcuts. So half of the questions which came from algebra were lengthy. Then we look at the other important section, which is going to be calculus. You know the chapters in calculus: limits, continuity, differentiability, differentiation, and integration up till differential equations. This is the big branch of calculus. Not many chapters here, but a very important unit. Again, 9 questions came from calculus. And 2 of these 9 questions were actually really interesting, tricky, difficult questions. A couple of moderately difficult questions were also there. And of course, a big number of really easy questions. Calculus is not a very lengthy section. The questions which come from here tend to be tricky ones, but not very lengthy ones. So a third of the questions which came from calculus were only lengthy. The rest, 2/3 of the paper from calculus was not very lengthy. Then we have 2 more sections. Coordinate geometry is one of those big sections, and coordinate geometry actually had 8 questions. Coordinate geometry covers chapters such as straight lines and pairs of straight lines, circles, all the conic sections, vectors, 3D. It's a big unit. And only 8 questions came from this big unit. And actually, to be very honest, questions from coordinate geometry never tend to be very difficult questions. And that was the case in this paper as well. Coordinate geometry didn't have many difficult questions. It did have a couple of moderately difficult or medium difficulty level questions. But a big proportion of the questions from coordinate geometry were easy questions. But because they are easy questions, they tend to be pretty lengthy. So coordinate geometry questions were very lengthy. Formula-based questions, a lot of memory was tested in coordinate geometry. But here and there were tricks of the trade which could have been used, and these questions could have been solved easily. But not every question had such tricks. So generally, coordinate geometry questions tended to be more lengthy. Finally, we are left with some miscellaneous chapters such as probability, statistics, mathematical reasoning. So these chapters put together, there were about 4 questions which came. Of course, permutation combination was included in probability. So there were 4 questions which came from PNC, probability, statistics, and mathematical reasoning. And no prizes for guessing. All these questions were very easy. Surprisingly, even the probability question which came was a very easy question. It was a dolly. So even probability shouldn't have been an Achilles heel to people who were expecting very high score in this examination. Statistics questions are inevitably lengthy because you will be given a set of observations, mean, variance, calculation. So statistics question is lengthy, but PNC, probability, and mathematical reasoning questions were definitely not lengthy. So the rest of this mathematics questions, they were easy questions, not really lengthy questions. So overall, I would say that the paper was really not a difficult paper. 21 out of the 30 questions were easy questions in my opinion. Only 3 of the questions were really tricky questions. The rest, of course, were moderately difficult. There were a good number of lengthy questions, so you should allocate a good amount of time to solve mathematics questions. 1 hour should be allocated to solve mathematics itself because mathematics tends to be a lengthy part of the JEE main paper. So we are going to pick a few questions and solve those questions here. In fact, I've picked 10 questions, really interesting questions. Some questions which would have been lengthy but had a shortcut to actually arrive at the solution easily. So I've picked some interesting questions. Of course, I'll be solving all the 3 difficult questions which in my opinion were there in this paper. And in addition to that, I'll also solve some interesting questions. So here are the questions which I find really interesting from this question paper. This first question is from the chapter on circles, and we have the concept of both circles and straight lines in this particular question. We've been given a straight line x plus y equal to n, where n is any natural number, and it has been told that this straight line makes intercepts with the circle x square plus y square equal to 16. The objective of this question is to find the sum of the squares of all possible intercepts. So first of all, let's try and understand what do we mean by a straight line making an intercept with a circle. So here is the circle x square plus y square equal to 16. It's a circle with center at 0, 0 and radius equal to 4. And then we have a family of straight lines x plus y equal to n. So x plus y equal to n is a family of straight lines whose slope equal to a -1. Now suppose we've been told that x plus y equal to n makes an intercept with the circle. It means that x plus y equal to n is a secant to the circle in this particular way. Okay, so now the meaning of the intercept in this particular question is the distance of the line segment of the secant inside the circle. That's what is the intercept of the straight line with the circle. So we have to find the distance between the 2 points of intersection of the line and the circle. That's what we have to find in this particular question. So first of all, which all lines x plus y equal to n can make intercepts with the circle? That's something that we need to find out. So in this particular position, the straight line cannot make an intercept with the circle. In this particular position, it can make an intercept with the circle. So what is the condition? Well, when the straight line is a tangent to the circle, then the shortest distance between the center and the straight line is going to be equal to the radius of the circle. If the shortest distance is less than the radius of the circle, then that line will be a secant and it will make intercepts with the circle. So the first condition is going to be the fact that the shortest distance between the center of the circle and the straight line has to be less than the radius of the circle. So what is the shortest distance of x plus y equal to n from 0, 0? Well, we will rewrite x plus y equal to n as x plus y minus n equal to 0. This is the standard form, and then we will substitute for in the distance formula, that is we will have ax1 plus by1 plus c divided by under root of a square plus b square. Here a is 1, b is 1, c is -n, and x1 y1 are 0, 0. So it's going to be simply nothing but n divided by root 2. That's going to be the shortest distance between the origin and the straight line, the center of the circle and the straight line. This shortest distance has to be less than the radius of the circle. So n divided by root 2 has to be less than 4, or n has to be less than 4 root 2. Now remember, in the question it has been told that n is a natural number. 4 root 2 is about 5.6 because root 2 is 1.4. 4 root 2 is about 5.6. So n can take the values 1, 2, 3, 4 and 5 according to this particular condition. N cannot take any other values for the line to make intercepts with the circle. Now, how do you find the length of the intercept? Or in fact, in this question, how do you find the intercept itself? Because the intercept is the length of the secant inside the circle. So how do you find that intercept? So we're going to make use of the Pythagorean theorem. Look at this particular point here. So in this particular point, the origin and the shortest distance of the straight line from the center of the circle, this is going to be one of the legs of the right triangle. Half of the intercept is going to be another leg of the right triangle, and the radius is going to be equal to the hypotenuse. So the intercept is going to be 2 times it's going to be 2 times under root of the radius square, 4 square, minus the shortest distance square, that's going to be n square divided by 2. This is going to be the intercept. Now we need the square of the intercept. So the square of the intercept, now we need that. So the square of the intercept is going to be 4 times this value without the under root. So it's going to be 4 times 4 square minus n square by 2. So we know the values that n can take: 1, 2, 3, 4, 5. Let's see if 1, 2, 3, 4, 5, everything is possible because we have an under root term here. Well, 5 square by 2 is less than 4 square. So of course 5 square is also possible. So all the 5 things are possible. So the sum of the squares of all possible intercepts, that's going to be 4 times. I'll take all the 4's common out. 16 minus a half. Plus 16 minus 2 square by 2, that is going to be 4 by 2, plus 16 minus 9 by 2, plus 16 minus 16 by 2, plus 16 minus 25 divided by 2. Well, there are 5 16s there, and 1 plus 4 plus 9 plus 16 plus 25 divided by 2 has to be subtracted from that. So we get 4 times 80 minus 1 plus 4 plus 9 plus 16 plus 25. That turns out to be 55. That is 50 plus 4 plus 1. That's going to be 55. So you will have a 55 divided by 2. And this is what is going to be the value. That's going to be 320 minus 55 into 2. That's going to be 110, which will give me a value of 210. So the correct answer to this question is that option which says 210. Very interesting question, slightly convoluted because you have to understand when will a straight line make an intercept with the circle, and then of course you have to understand that the implied meaning of an intercept in this question is the length of the secant inside the circle. These are the slight tricks in this question. After that, of course, it's a very straightforward question, no shortcuts available. You have to solve this question in a very systematic way. Now let's look at an integration question. Now in this indefinite integral question, we have to find the integral of sine 5x by 2 divided by sine x by 2. Now how do you go about this question? It's a little tricky because the first step, visualizing that is a little difficult. Once you get that, from then on it's a very routine question. So what do we do first? The first thing that we are going to do is we are going to multiply and divide by cos x by 2. So when I divide and multiply by cos x by 2, in the numerator, I have a sin c cos d term, and I have the trigonometric relation to find out what is the expression for 2 sin c cos d. I can rewrite it in simpler terms. And in the denominator, I have sin x by 2 cos x by 2. If I multiply that by 2, I actually have sin x in the denominator because it's 2 sin x by 2 cos x by 2, which is nothing but sin x itself. So what I'll do is I'm going to multiply by 2, divide by 2. In that way, what will happen is my numerator will be nothing but 2 sin c cos d. 2 sin c cos d is going to be nothing but sine of c plus d plus a sine of c minus d. So sine of c plus d, 5x by 2 plus x by 2, that's going to give me 6x by 2, which is nothing but 3x, plus sine of c minus d, 5x minus x all divided by 2, 4x by 2, that's going to be sine 2x all divided by sine x. Now we still don't know what to do with that sine x in the denominator, but luckily we know the expression for sine 3x and sine 2x. The expression for sine 3x is 3 sine x minus 4 sine cube x. Again, sine x are there in both the terms. The expression for sine 2x is 2 sine x cos x. Again, sine x is there, which means every sine x in the numerator will be cancelled with the sine x in the denominator, which means we can do away with the sine x in the denominator. So I'm going to rewrite this as integral of 3 sine x minus 4 sine cube x, that's the expression for sine 3x, plus 2 sine x cos x, that's the expression for sine 2x, and divide this entire thing by sine x, and of course we have to integrate with respect to x. Now you can see that I can very easily cancel out one of the sine x's from each term in the numerator, and my integral simplifies to integral of 3 dx minus well, I still have a sine square x there. I don't know how to integrate sine square x, so I'm going to write a sine square x in terms of cos 2x. 2 sine square x is 1 minus cos 2x. So I have 4 sine square x. That's going to be nothing but 2 times 1 minus cos 2x dx. Plus I have an integral of 2 cos x dx. Now this is an integral that is very, very easy to solve. So I have integral 3 dx here and negative 2 dx from this term. So which means overall I have an integral 1 dx or integral dx, which gives me, so integral dx will give me that's equal to just an x. The next term that is going to be there is minus of cos 2x, which is going to be a plus integral of 2 times cos 2x dx. And of course, the last term is nothing but integral of 2 cos x dx. So this is going to give me a 2 times sine 2x divided by 2. So the 2's will cancel out. And this will give me a sine x with a 2 outside of it. So the correct answer to this question will be x plus sine 2x plus 2 sine x. Of course, it's an indefinite integral, so the constant of integration is very important. So the first step in this question was slightly tricky. Once you get that, this question is very easy to solve. The next question that I'm going to solve is a question which is based on properties of combinations. So it's something that is going to deal with the properties of NCR. So in this question, we have to find the summation of this series. The series is 2 times 20C0 plus 5 times 20C1 plus 8 times 20C2, so on up till 62 times 20C20. We have to find the sum of this series. And of course, we have to make use of properties of combination in order to arrive at the solution. So the first thing that we need to do here is we need to find the general term. So one part of the general term is going to be 20CR, where R runs from 0 to 20, because we have 20C0, 20C1 up till 20C20 as one part of that term. But there's also a coefficient which is being multiplied to this combination. So let's try and find out what is the pattern that this combination forms when R runs from 0 to 20. So when R is 0, we have 2, and when R is 1, we have 5. When R is 2, we have 8. So this means that we are going on adding 3's to each of the consecutive terms. When R is 20, we have 62. So what if I write 3R plus 2 when R runs from 0 to 20? Well, when R is 20, we do get 62. When R is 0, we get 2. R is 1, we get 5, and so on. So the general term is going to be 3R plus 2 times we have 20CR. So now we have to find the summation of this. So the objective of this question has to be mathematically rewritten in a different way, which is summation R running from 0 to 20 of 3R plus 2 20CR. This is the easier way of solving this question than, of course, computing all the 21 combinations and then multiplying them with the corresponding terms. That's not how we are going to solve this question in the examination. Okay, so now we have 2 terms here. We will split both the terms. One term is going to be 3 times summation R running from 0 to 20 of R times 20CR, and the other term is 2 times summation R running from 0 to 20 of 20CR. Now we know what is this. This is very easy. Summation R running from 0 to 20 of 20CR is nothing but 2 to the power 20. That's as good as solved, but we need to solve this. And this is where your understanding of properties of combination and in the summation context comes into picture, because the summation R times NCR, that is going to be nothing but n times summation of n minus 1 CR minus 1. So this will actually become 3 times 20 times summation R running from 1 to 20 now. The index has changed as one less term, and your combination is changed to 19C R minus 1. So now we know what is this term here. This term is going to be nothing but 2 to the power 19 because we have one less term here. So this the summation of that is going to be 2 to the power 19. So this question is as good as solved. We have 3 times 20, which I can rewrite as 60 times 2 to the power 19 plus of course 2 to the power 20. That is multiplied by a 2, so it becomes 2 to the power 21. Now this question is all about mathematical manipulation to arrive at the solution according to one of the options. So 60 times 2 to the power 19 can be written as 15 times 4 times 2 to the power 19, which is nothing but 15 times 2 to the power 21 plus 2 to the power 21, which is nothing but 16 times 2 to the power 21. So the correct answer to this question is nothing but 16 times 2 to the power 21. Moving on, let's look at a question from sequences and series. So in this question, the objective is to find the sum of all the natural numbers. Now, what are these natural numbers? These natural numbers are between 100 and 200, and also their HCF with 91 is more than 1, which means that these natural numbers and 91 have at least one common factor other than 1. So let's look at this question. It's an easy question, but I think it's going to be a little high on computation. So let's get ready for some mathematical calculation, arithmetic calculations, and get into this question. 91 is nothing but 13 times 7. So we have to find out all the numbers between 100 and 200 which have 13 as a common factor and 7 as a common factor. So this means we are going to find the multiples of 7 between 100 and 200 and the multiples of 13 between 100 and 200. So the multiples of 7 are 105, which is nothing but the 15th multiple of 7, 112, which is the 16th multiple of 7, so on until 196. 14 14s are 196, so that's going to be 7 times 28. All such quick mathematical arithmetical knowledge is going to be very, very useful in such questions. What about 13? 13 eighths are 104, so we have the 8th multiple of 13, which is 104, when we have 117, which is the 9th multiple, and so on until 169 is 13 square, 182, 195, which will be the 15th multiple of 13. So overall, if you see, there are 14 multiples of 7, total of 14 multiples, and in the other case we have a total of 15 minus 8 plus 1, that's going to be 8 multiples of 13. So we need to find the sum of these two arithmetic progressions. Now these are nothing but arithmetic progressions with a common difference of 7 and 13 respectively. So the sum of the first arithmetic series, that is going to be 14 divided by 2 first term plus last term, 105 plus 196. That's going to be 7 times 301, which is nothing but 2107. The other second series is an arithmetic progression with 13 as its common difference, and there are 8 terms, so 8 divided by 2, 104 plus 195, that's going to give you 299 times 4, which gives you a total of 300 into 4 is 1200, so this gives you 1196. So if you add these two terms, you should get the answer to this question, or will you? Well, you'll get a wrong answer, because you have to remember that multiples of both 7 and 13 have been added 2 times here. And let's try and find out how many multiples of 7 and 13 are there. There's only one multiple of 7 and 13. That's going to be 7 into 13, which is 91, into 2, which is 182. So you have to subtract 182 to get the correct answer. To the final answer, your summation that you were looking for was nothing but 2107 plus 1196 minus 182. So these two when added, well, they are going to give you 3303. Well, from 3303 you have to subtract 182. So the final answer to this question will be 3121. So the correct answer to this question is 3121. Well, this is a question which is very high on arithmetic calculations. N number of places where you can go wrong, so be a little careful when you're doing all these arithmetic calculations. Otherwise, this question is actually a very simple question. The only trick was that 182 was being added twice, so you had to subtract 182. Now let's look at a question from system of equations. This is a very simple question. We've been given three equations. These are the three equations. And it has been told that these three equations have no trivial solutions. So we have to find out the value of C for which this system of equations have non-trivial solutions. To be very honest, I would solve this question even without lifting the pen, because if I look at equation 2 and equation 3, what do I see? I see that the coefficient of y and z in equation 2 and 3 are exactly the same. So if I have the coefficient of x's to be exactly same, then the system of equation will definitely have non-trivial solutions. So if negative c equal to 1, so if my negative c is 1, then of course the system of equation will have non-trivial solution. So c equal to minus 1 is definitely a value of c for which the system of equations has non-trivial solutions. C is equal to minus 1 is one of the options given. This is a single correct answer type of question. So definitely c equal to minus 1 is what I will mark. Now, for those of you who don't know this and who want to solve it in a systematical, mathematical way, then you will have to go make use of determinants and try and find out values of C for which the system of equation will have non-trivial solutions. I will also show you that method. So for a system of equation to have non-trivial solutions, then the coefficient matrix should have a determinant equal to 0. So C minus 1 minus C 1 minus C. 1, 1 minus c, the determinant of this matrix should be equal to 0. So I will solve this using properties of determinants. I'm going to write a c1 as a c1 minus c3. So if I do c1 minus c3, what I will actually get is I will get a c plus 1, 0, c plus 1 here. Minus 1, 1, 1, minus 1, minus c, and this determinant has to be equal to 0. From the first row, from the first column, in fact, I can take c plus 1 common out, and if that determinant has to be equal to 0, c plus 1 can be 0. So for c plus 1 equal to 0, the value of this determinant will be equal to 0. So c plus 1 equal to 0 is one of the solutions. So from that, I get c plus 1 equal to 0 or c equal to minus 1. Exactly like how I got the solution without solving the determinant. Maybe there are more values of C for which the system has non-trivial solutions, but this is again, remember, single correct answer type of question. So if C equal to minus 1 is one of the options, we're just going to mark that option and move on to the next question. Now let's look at a differentiation question. In this question, we've been given a function definition 2y equal to cot inverse of root 3 cos x plus sin x divided by cos x minus root 3 sin x the whole square. The objective is to find out dy by dx. But in such questions where the function definition has an inverse trigonometric function with trigonometric functions in the argument, we don't directly go to differentiate. What we do is we try and simplify the function statement as much as possible using the properties of trigonometry and inverse trigonometry, and then differentiate the function once we have simplified it as much as possible. And in fact, here we can simplify it very easily, because I see root 3 cos x plus sin x in the numerator, cos x minus root 3 sin x in the denominator of the argument, and as soon as I see this, I know the drill. I need to divide the numerator and the denominator by 2. So I'm going to divide all these terms by 2. So what I will get is root 3 over 2 cos x plus half sin x in the numerator, half cos x minus root 3 over 2 sin x in the denominator. Now root 3 over 2 cos x plus half sin x can be rewritten as a cos pi by 6 cos x plus 1 half, which is nothing but sin pi by 6 sin x. Now this is nothing but cos of x minus pi by 6. Cos of a minus b is cos a cos b plus sin a sin b. So that's what this is. In the denominator, I have 1 half cos x, which can be written as sin pi by 6 cos x. I'm going to stick with pi by 6 and not pi by 3 because in the numerator I've used pi by 6. Minus root 3 over 2 is cos pi by 6 into sin x. So this is cos sin a cos b minus cos a sin b, which is nothing but sin of a minus b, which can be written as sine of, remember this is now not going to be x minus pi by 6, but it's going to be sine of pi by 6 minus x. So now what I have here is 2y equal to cot inverse of, well, the numerator is going to be cos of x minus pi by 6 divided by sine of pi by 6 minus x. And this entire thing has to be a square. So this is what we get in the function definition. So now we have to rewrite these things and simplify them, but cos over sine would have been cot, but their arguments are different. So what we can actually do is that we can write cos of minus theta as cos theta and rewrite this as cos of pi by 6 minus x. So then we will get 2y to be equal to cot inverse of cos pi by 6 minus x divided by sine pi by 6 minus x, which is nothing but cot pi by 6 minus x. So we have all of this squared. So I eventually get 2y to be equal to pi by 6 minus x the whole square. Well, pi by 6 minus x the whole square can also be written as x minus pi by 6 the whole square. That's going to make my life of differentiating easy, because chain rule, using chain rule, the differential of x is going to be just 1. So now I can write the differential of this. It's going to be 2y dash. Y dash is nothing but dy by dx. That's going to be equal to 2 times x minus pi by 6 into 1. So the 2's are going to get cancelled, and eventually I get the answer y dash or dy by dx to be equal to x minus pi by 6. So the correct answer to this is x minus pi by 6. So the only thing that was necessary in this question was to ensure that you simplified the function definition before you got on to differentiation. Okay, so now let's look at a question which is an application of derivatives question. Now this question is a little tricky. Now this is not a very lengthy question, but you actually need to understand the concepts of monotonicity very well to be able to solve this question. We've been told that f double dash of x is greater than 0. So the second derivative of f is actually a positive number for all x in the interval 0 to 2. Further, another function has been defined, a function phi of x has been defined as f of x plus f of 2 minus x. Now the objective of this question is to find out the nature of phi of x, so the monotonicity of phi of x, in which interval phi is decreasing, in which interval it is increasing. That's what we have to find out about phi of x. So let's try and solve this question. The first thing we know is f double dash of x is greater than 0. This means that f dash of x is an increasing function, is always increasing, is an increasing function in the entire domain, let's say 0, 2, that's the domain of interest for us. So f dash of x is an always increasing function in this domain. Now what is phi dash of x? Phi dash of x is going to be f dash of x plus f dash of 2 minus x, and do not forget the chain rule, so there's going to be a minus 1 here. So that's going to be nothing but f dash of x minus f dash of 2 minus x. Now the domain is 0 to 2. So let's divide this domain into two subdomains, 0, 1 and 1, 2. The reason I do that is because in 0, 1, x is going to be less than 2 minus x. Agreed? When you put x equal to 1, x is equal to 2 minus x. Less than 1, x is less than 2 minus x. More than 1, x is going to be greater than 2 minus x. So this is going to be in the interval 0, 1, and this is going to be in the interval 1, 2. Now what do we know about f dash? F dash is always increasing. So if x is less than 2 minus x, f dash of x is less than f dash of 2 minus x, because f dash is a monotonically increasing function in the entire domain. Similarly, f dash of x will be greater than f dash of 2 minus x in the other subdomain. So what is phi dash of x? It's f dash of x minus f dash of 2 minus x. So if f dash of x is less than f dash of 2 minus x, so if f dash of x is less than f dash of 2 minus x, this happens in the subdomain 0, 1. So in this subdomain, phi dash of x, which is nothing but f dash of x minus f dash of 2 minus x, that's going to be negative. This means phi of x is going to be a decreasing function in this subdomain. what happens in the other subdomain, which is 1, 2. In this other subdomain 1, 2, we have phi dash of x to be greater than 0, because in this subdomain f dash of x is greater than f dash of 2 minus x. So phi dash of x is greater than 0, which implies phi of x is an increasing function in this subdomain. So the correct answer to this question is in 0 to 1, phi is a decreasing function. In 1 to 2, phi is an increasing function. A very interesting question on application of derivatives, a question which was very high on analysis and understanding rather than actual process of differentiation. Let's get into coordinate geometry now and solve a question from straight lines. Now in this question, we have been given a straight line 3x plus 5y equal to 15, and we've been told that a point P lies on this line 3x plus 5y equal to 15 such that it is equidistant from both the x and the y axis. We have to find out the quadrant in which P lies. Now, I'm not going to solve this analytically. Of course, I will show it to you at a later time, but the first thing that I'm going to show you is the easiest method to solve this question. So, if the point P is equidistant from the x and y axis, this means that that point P also lies on the straight lines mod x equal to mod y. So mod x equal to mod y is a pair of straight lines on which this point P has to lie to be equidistant from both the axes. So x equal to y, x equal to minus y. These are the two straight lines on which P has to lie. So the point of intersection of these two straight lines and the straight line 3x plus 5y equal to 15 is where point P is going to lie. So we're going to solve this graphically. So 3x plus 5y equal to 15. Its y-intercept is 3, its x-intercept is 5. So this is how the straight line is going to lie. So it's going to lie in the first quadrant, it's going to be in the second quadrant, and it'll move on to the fourth quadrant. It'll never be in the third quadrant. Now, x equal to y will intersect this particular line in the first quadrant. So there's definitely going to be a point which is equidistant from the x and the y axis on this particular line in the first quadrant. And if you look at the options, first quadrant is given. So this means that the first quadrant is definitely a correct answer to this question. You will mark that, and because it's a single correct answer kind of question, first quadrant is the right answer. Now, x equal to minus y or minus y equal to x could have intersected this in the second or the fourth quadrant. But if you are a smart kid, you will know that fourth quadrant is given in the option, second is not given. This means that it cannot intersect in the fourth quadrant because there cannot be two correct answers, because first quadrant is definitely a correct answer. So the other point is going to lie in the second quadrant. So the 2 points where P will lie will be the first and the second quadrant. The only option given is the first quadrant. That is the correct answer to this question. But then of course, if you cannot solve a question graphically in this way, this question can be actually solved easily analytically as well. I'm going to show you that. So we know that for a point to be equidistant from both the axes, it's going to lie on the pair of straight lines mod y equal to mod x, or y equal to x and y equal to minus x. On these two straight lines, the point P has to lie. So this means that point P, which also lies on 3x plus 5y equal to 15, has to be on the point of intersection of these two lines and 3x plus 5y equal to 15. So the first point y, we'll put y equal to x, we'll get 3x plus 5x equal to 15. Or x equal to 15 divided by 8. Of course, y will also be equal to 15 by 8. 15 by 8, 15 by 8 lies in the first quadrant. See, this is the point P. We were never asked the coordinate, so we easily could conclude that there is a point in the first quadrant where P lies. Now, if y was equal to minus x, then we would have got 3x minus 5x equal to 15, or x to be equal to negative 15 over 2. Which means that y would be equal to minus x, which is 15 over 2. A negative 15 over 2, 15 over 2 is a point which lies in the second quadrant. So see, there is another point P which is in the second quadrant. So the 2 points P would be on the first and the second quadrant. The only correct option is the first quadrant. And we actually arrived there in about 15 seconds, isn't it? As soon as you saw the question in 15 seconds, you could have arrived there. You did not actually have to lift your pen at all. It's actually a very simple question. Do it graphically and not analytically. The next question that we're going to solve is from theory of equations. Now this is going to be an intense question because it's a quadratic equation question, but it also has an under root term and modulus in the equation. So it's going to be a lengthy question, so get ready for that question. Here is the question. So in this question, we have to solve the equation, which is mod of root x minus 2 plus root x times root x minus 4 equal to 2, and find out the roots and add all the roots, because the objective is to find the sum of the roots of this particular equation. So how do you solve this question? Well, first of all, let's open the bracket that exists there and try to simplify that. So I get root x minus 2 in the mod. I'm not going to touch that for now. Plus root x into root x, which is nothing but x, minus 4 times root x, that's equal to 2. So if I look at the term which is outside the modulus in the left hand side, I have an x minus 4 root x. So x is root x the whole square, and of course I have a minus 4 root x, which is nothing but 2 times root x times 2. So if I actually add a 2 square to both the sides, I can rewrite this as a root x minus 2 the whole square. And look at what is inside the mod. That is also root x minus 2. So this is what you have to see as soon as you see this question. This is an important bit in this question, because if you get this right, from here everything is going to be easy, because now your equation is nothing but root x minus 2 the whole square, which is nothing but mod of root x minus 2 the whole square, because whole square is always going to be a positive term. So you can as well add a mod and square. It's going to not change it. Plus mod x minus 2, mod of root x minus 2, and you have a 6 on the right hand side, that I'm going to write as minus 6 equal to 0. So now you actually have a quadratic equation, but your variable is mod of root x minus 2. So that's your variable. So this is nothing but t square plus t minus 6 is equal to 0 if my t is nothing but mod of root x minus 2. That's my new variable. I have to solve this quadratic. That's a very easy quadratic to solve. The factors are going to be t plus 3 and t minus 2. So upon solving this quadratic, I'm going to get t equal to negative 3 and t equal to 2. But what is t? T is mod of root x minus 2, and a mod cannot be negative, so this is rejected. T has to be equal to 2, so mod of root x minus 2 has to be equal to 2, or this means mod of root x minus 2 or root x minus 2 equal to plus or minus 2. If the right hand side is minus 2, the minus 2's will cancel out and I will get root x equal to 0 or x equal to 0 as one of my solutions. If the right hand side equal to 2, then I have root x equal to 4. If root x equal to 4, then x will be equal to 16. So the two roots of that complex looking equation consisting of under root and mod were 16 and 0. The sum of the roots is very simple, 16. So sum of the roots is nothing but 16. The correct answer to this question is 16. Very nicely designed question. Of course, you had to see that first bit of trick, which was completing the square. If you got that right, then solving this question was very easy. And finally, we are going to look at a question from ellipses. So in this question, we've been given an ellipse, which is 4x square plus y square equal to 8. And we've been told that the tangent to this ellipse at the point 1, 2 and the tangent at the point a, b are perpendicular. The objective is to find out the value of a square. Now, there are multiple methods to solve this question. The standard method would be use the equation of the ellipse, then find the tangent to the ellipse, the equation of the tangent to the ellipse at a point, and then find the slope of that tangent at these 2 points, and then equate m1, m2 equal to minus 1 and find out things. I'm not going to do that because it's going to be a very lengthy method. I'm going to use my understanding of slopes from differentiation. So at any point, the slope of the tangent to a curve is nothing but the derivative of that curve. I'm going to use that knowledge here and not use the equation of tangents. So I have 4x square plus y square equal to 8. I'm going to differentiate that to get 8x plus 2y dash is 0. which means my y dash will be nothing but, of course, a negative 8x by 2y or negative 4x over y. The slope of the tangent at any point to this ellipse is going to be negative 4x over y at that point x1, y1. So at 1, 2, the slope of the tangent will be equal to nothing but negative 4 over 2 or negative 2. So the tangent at a comma b is perpendicular to this. So at a comma b, the slope is going to be equal to minus 1 over minus 2 or half. Correct? So my half is going to be negative 4a over b, or I get b to be equal to negative 8a. But remember, a comma b are points on the ellipse, so they satisfy the equation of the ellipse. So I get 4a square plus b square, which is nothing but 64a square, to be equal to 8, or I get 68a square to be equal to 8, a square to be equal to 8 by 68 divided by 4, both on the numerator and the denominator, and you will get 2 divided by 17. The correct answer to this question is 2 divided by 17, and look at how easily I solved this question. If you were to use the equation of a tangent to arrive at this, it would have been really complicated. Moreover, you might have had to use the parametric form of an ellipse to arrive at the answer much easily. But we've done away with all those complexities, and we solved this question very easily using the techniques of differentiation. So an ellipse question which we solved using the techniques of derivatives. So the first paper of the JEE main examination conducted in April 2019 was not a very difficult paper from mathematics point of view. Just 3 questions, or 10% of the paper in my opinion was difficult. The rest of the paper was actually very easy. This paper could have definitely been solved in 1 hour or less. It was just important that you knew some of the tricks of saving time and arriving at solutions faster than conventional methods. I've shown some of the tricks in this video. For more videos of this kind, please subscribe to our channel. And of course, I'll be back with many more videos. Until then, see you. Bye-bye.
For more videos and live lectures on the JEE, click on the subscribe button now.